Uh, Hello everyone. Assalamualaikum. Very good morning. So we are going to proceed with the lectures, and end of the lectures we are going to have another 10 questions assessment. So please help to do it in Ulearn. And on the next sessions, we are going to have more on the hands-on. So after these topics, I think that I'm going to work on the programming. So still we have an assessment on that. So this is going to be on the Thursday morning, Thursday afternoon. Okay, for today's class, that we're going to proceed with the slides. We are talking about interrupts. So what is all about interrupts? It's actually a mechanism of microcontroller which enables it to respond to some events at the moment when they occurs, regardless of what microcontroller is doing at the time. So each interrupt changes the program flow, interrupts, and after executing an interrupt program subroutine, it continues from the same point on. So what is interrupts? So in bahasa Melayu is actually menyampuk, right? Actually you are talking in the middle of something. You are actually try to break the current conversations and you try to talk with him. So it's very simple. The analogy is like this. Okay, let me draw you something. So just imagine that this is your microcontroller. This is your microcontroller, and he's doing actually try to fix his car. I mean, his car is breakdown, right? So he's doing this one. So this is somebody else. They call this guy is interrupt. So what happened in interrupt? So you just imagine that your program is actually fixing a car. It's actually going to do this looping is going to be keep on looping fixing a car. So this interrupt guy is actually another task, which is to give drink to the microcontroller. So what happened is this interrupt will go here and maybe pat his shoulder. Hey guy, I need to give you something here, and then he'll talk to this guy and he give a drink to him. Then this guy will drink, and after that this guy finish, then he will go. So means that by having this program, suddenly you can interrupt this guy to stop for a while and then complete your task, which is to give his to ask him to drink, and after that is complete, and then you can go, and then he's continue back his work, which is to fix a car. So that's why they call it interrupt, a process that you can change. I mean, the process that you can interrupt, you can give something to the microcontroller, and then the microcontroller will do the task that you want to do, and then after you complete, and it will go back to the normal process. So that is the interrupt. Okay, the interrupt sources for microcontroller for PIC, there are 3 of them. One, they call it external interrupt on pin RB0 interrupt. So I just go directly back to the pins last time. If you can remember that, pin 1, let's just go, for example, I just go open up that one. Just hold on there. This one, I think this one, not this one. If you can go to the pin diagram again, there is a pin named RB0 interrupt. You can see that this is actually the pin that we used before for the digital I/O. It also can be used as interrupt. So this pin, you have to connect to a switch. For example, this is power 5 volt, and you can go for a switch here. This is going to ground. So this is actually going to be a switch, so means that the input will based on this one. As long as there's no input here, I mean there's actually 5 volt, the system will keep on doing its same process, the main process over here. Once you push this button, and then this pin will be triggered 0 volt, and then the process of the interrupt happens, and the task in the interrupt is completed. It's actually going to be processed, and after finish you go back to the main program. So that is the first external interrupt that we have. External means luaran, means that you have to work with the pins. So that is the first source. They call it RB0 interrupt, which is a pin RB0 over here, which is the interrupt here. The second one, another external, this is also external. I will tell you this is external interrupt, which is a changes on port B, RB4, pin 4 to pin 7, sorry, port B. Alright, this is external, means that you have to look at the external pins here. So again, for the another sources of interrupt, you are going to play with these 4 pins. That's why they call it external. You have to give input to it. Okay, so that is the second one. So this is the first one, second one, and the third one they call it timer 0 counter overflow. This is internal interrupt. This is going to be a one topic, so I'm going to touch this one very deep, is at that topic particularly. So what you need to understand now, you have 3 interrupt sources. One, they call it external here for interrupt, for RB0 pin interrupt. The second one, they call it pin, the changes on RB4 to 7 here. Okay, so in micro C, your program micro C, it will recognize an interrupt routine to be executed as a void interrupt. What does it mean void interrupt means? This is a name, this is a subroutine name for any interrupt. For micro C, you can write down as void interrupt. For example, this is the routine, and the process that you want to do in the interrupt with this one. If you can remember back in C++, void interrupt, this is the body of it. So you can see it as the main body, or actually another one as a subroutine. So when you create a subroutine in C++, you're going to have this one, void integer. This is the names of the subroutine, and then its body. So this is actually the one that you have to go back to C++. So no matter what, micro C can recognize and interrupt by writing this subroutine. For example, okay, let me show you how it works. For example, how the program will look like that. So this is actually the program that we have for interrupt. You can see that this is your main body, void main, and the while one loop. This is your main body. So you have a subroutine here, they call it void interrupt. Okay, that's this is actually the subroutine, or the command, the process that you want to do when the interrupt happens. So in micro C, you have to write down void interrupt. The name will be interrupt, not void BEKM, cannot be like that. Even though you can create all these names like void, whatever functions that you want to call, but in interrupt process for the micro C, you have to do it void interrupt. Okay, that is the process how to write down the interrupt. Okay, so again, look at this one. This is an example of RB0/interrupt. This is again pin RB0 here. So you can see that this is connected to a switch. When the switch is turned on, I mean this is going to be triggered 0 volt. Initial is going to be 5 volt. When you push this button, it's going to be 0 volt here. This is the lowest resistance here. It's going to be 0 volt. And once this 0 volt is active, then what happens is actually when the program is executed, this is your main program. This is your main program. Once this is executed, it will go to the interrupt function and do the subprogram where the interrupt is processed, After finish, then we'll go back to the normal flow execution. So as long as this is not pushed so many times, it will go back to the programs, keep on doing the main program over here. If you push the button, it will go here, do this one, and then go back here, finish, go back here. So this is the process. Okay, right, let's move on. Where is it? So the register that you need to work with for the setup of the interrupt, there is a name, there's a one register very important that you need to remember, that they call it incon. Remember that this is a name of the register. So you can go back to the memory last time for the RAM. You can see that one of the register name is incon. This is the short form for the interrupt control registers, they call it. The function is to allow or disallow interrupts. This is where you can set up your interrupts, which type of interrupts that you want to use. Okay, so if you can go to the datasheet for the PIC, I already extracted out what is the incon registers. So the size is, again, is 8-bit size, from bit 0 to bit 7, and this is where you have to change the value. Let me change the color. You can change the value inside here, which is maybe 100, 01, 001, something like that. You have to change. So when you want to change, right, you have to read what is the functions when you change the value 1 or 0. For example, the first one, GIE. GIE, when you want to change it, this is the global interrupt enable. This is the main setup for the interrupt. So this is where you have to enable it. You have to put 1. For example, here you must put here 1. So the rest, it depends on what type of interrupt that you want to use. So you can see that from here we have the PEIE. This is normally we don't use it. So you have the timer 0 overflow interrupt enable. This is where you enable the timer 0 interrupt. This is to enable RB0 external interrupt. This is to enable the RB4 to RB7 interrupt. And the last 3, this is very, very important, that these last 3 bits is going to be related to the 3 interrupts that you are going to set up. For example, for the timer 0, it will relate to this one. This is the flag. So RB0 interrupt will be going here, and RBIE is going to be up here. So all these 3 is, they call it flags. What do you mean by flags? Flags means if your interrupt is activated, then the flag will be changed to 1. Means that your system know that interrupt had happened. This is done by the system. This one you set up, right? For example, here for these flags, right? When you see this one, when you push the button, so for example, just now when you push this button, let me go here. When you push this button, the RB0 internal will be RB0 RB0 interrupt will be activated. So means that the flag at interrupt for the RB0 will be changed to 1. So this one is going to be here, will change to 1. From 0 we're going to change to 1. Say that the interrupt had happened. So what happened is the system see this one as 1, then it will go and execute the void interrupt subroutine. Complete that, then it will go back to the main program. So you can see that here, for the flag for the timer 0, for the flag for the time for the RB0 interrupt, you can see that timer 0 register has overflow must be cleared in software. This is the big statement, must be cleared in software. Must be cleared in software. Cleared means from 1 to 0. What happened is when the interrupt executed, the flag is going to be 1. So after the task is completed, you must clear it from 1 to 0 back. So means that the normal condition will be back. By default, there is no more interrupt. So this is going to be the one that you need to keep on doing this in your interrupt subroutine, because you must clear it in software. Else, if you are not clear it, which is clear from 1 to 0, if you do not clear it, this value is going to be 1 all the time. Means that the system thinks that the interrupt is keep on continuously happen. So that's why you have to clear it back to 0. Okay, so I'm going to show you guys how it's going to work in the program. Okay, let's move on. So this is the register that you need to change when you want to do the interrupt programming. Yeah, alright, so let's move on. So this is example only, so just remove this one. I don't want to see this one. So you have 8 bit for the interrupt register control, right? So you can see that there are two the bit is actually related to another one, which is the flag here. This is a flag, and this is the types of interrupt that you want to use. This is global IE, which is the first one here, and the rest is actually going to be the partner for it, TOE. This is its flag, this is its flags, and the last one is this flag. So this is timer 0. This is a interrupt for RB0 interrupt pin, and this is RB4 to 7. So this is the enable pin, enable bit for the interrupt that you want to use, and this is the flag that which is going to be happen when the interrupt executed, when interrupt is activated. Okay. So for timer 0, okay, for this one, for timer 0, there is another register that you need to learn, but this is not going to be touched today. So the register is called option right. This is going to be touched in the timer 0 control. So the first one just now we learned about the incon. This is just a name for you. You just need to learn about the option register, incon and option register. Okay, so I'm going to touch this one in timer 0 topics. So let's proceed. You can see that again, this is where the interrupt just now we discussed. The first one is external. This is also external. Again, I will have to put his one as external. This is internal. This is the sources, and where you can use any of these sources to put as your interrupt. Okay, right, let's move on. Okay, here, this is the program that possibly you can use to write down the interrupt for RB0 here. So I'm not going to use this one. You can try this one later, but I'm going to show you a very simple one for the program here. Let me open up my code here. This is my project. See. Okay, this is the code you can write down here. You can see it. Hopefully you can see it. So this is the main body when I write down here. So this is the one that you need to do. Okay, this program is going to be using the interrupt for RB0 interrupt. So means that for RB0 interrupt, you have to declare the RB0 pin as input here. The rest you can declare it as output. Okay, so this one I declare all the port B as 05 volt. Try C is the one that I'm going to use as the output. Try C, port C, all the levels for the port C now is at 000 or 0 volt. So this is the first settings for me to do the interrupt configuration, which is interrupt control here. So I'm going to change it to 0B1001000. So you go back to the this one just now. So the income register is 1001,000 here. So this is going to be 1001. This is 0000. So I'm going to enable this one. INTE is for the RB0 interrupt pins. This is enabled here. This is global. You have to do it this one all one, because if you put this one 0 means you're all interrupt, you disable it. So this is global interrupt. So I'm going to enable this one first. So you can see that in this program I have enabled the interrupt, and then my main program is showing that port C is equivalent to this one, means that only one pin at port C is turned on. Okay, so this is your main program, right? It's keep on continuously happen. It keep on doing this one forever, means that the port C will be going to be turned on the last bit here. I'm going to show you in Proteus. So when you hit the button for RB0 interrupt, you activate the interrupt, you will go to the interrupt function, which is going up here, and then this interrupt task is actually going to turn on one LED which is on the highest bit, which is bit 7, and then it will delay for 1 second. And this command is to clear back the INTF. Just now when we talk about the clear by software, this is how you want to clear it. When the interrupt happen, the incon.intf will be changed to 1. So what happened now, you have to go to this subroutine for the interrupt. In this subroutine, you must clear it by this statement. This is changing back the value from 1 to 0. Then it will go back here, doing this one. So how let's look at the Proteus, how are you going to work on this program. My Proteus, let me change my Proteus project, so RB0. So I'm going to remove this one first. No to make you guys okay. So this is just very simple, right? This is the what do you call that? This is the configuration for to use the RB0 interrupt. So I have this command already. So let's run this one. So the main program say that for this looping, I'm going to turn on one LED over here, which is correct. This is correct. This is the RC0, which is this RC0. Okay, now when I hit this button, because this is not yet executed, this is not activated for the interrupt. When I push this button, then it's going to be here. So I did not compile this one yet, so I'm going to compile this one. So sorry, I'm going to compile this one first, build. So push this one back. So I'm going to run this one again. So I push this button. Oh, it does not go back to normal. Sorry, I have to check this one. It must go back to normal. So this is my folder project hacker. This is yesterday night. This is 9:05 AM. So it's not actually you can see that there's a problem on this because I'm still using my old program. This is 12:32 AM, and this is be compiled just 9:05 AM. So I need to recompile again. So okay, close this one. Project this one. I think this is one. Yes. So this is the one. So this is going to be one again. Project. Build. Okay. So open up at this one again. So you can see that it's already compiled at 9:05 AM. So I'm going to run it. This is on for this one, right? This is on. And then my interrupt say that I'm going to turn on this one. Turn on this one for 1 second. Why is this not going back? This is sorry, I did not clear it. This is back to clear. sorry. So this is going to be the right one. And you can see that I touch this button, interrupt, go here, and then finish, go back. Push back, interrupt, go here, and then go back here. So this command state correctly. So the main program is going to turn on the LED for the last bit, which is this one. Okay, right? So then what happened is actually when I push the button for the interrupt here, because I did set up for my incon to use the RB0 interrupt pins. So when I push this button, activate it. So once it's activated, so it's going to flag 1. The INTF will be going to change to 1 in the software, and then we'll go to the interrupt function here, and then this command is to turn on one LED at this one and turn off the first LED just now, and then wait for 1 second, and then the command will going to clear. This is to clear by software the flag, and then you will go back to your main here. Keep on doing this. Okay, that's why you can see that this program is like this, and then you will go back, right? You will go back. Once interrupt done, this is actually done because the INTF had been cleared. So what happens if it's not cleared? Means that if I do not clear it by software. So let me check. I don't want to do this one. I remove this one, right? So I'm not going to change clear or from the flag from 1 to 0. So I'm going to run this one, build again. So you run this one. So if I push this button, this LED is not going to be turned off and go back to the main program again. Why? It's because that .intf flag is not cleared. So it means that the system thinks that the interrupt is consistently happen. It keep on thinking that the interrupt is happening, so it's going to be only at this interrupt portion, right? You go here and then this is always that interrupt. That's the reason why in the Slack just now it's telling you that one of the register bit, which is called INTF related to the RB0 interrupt, must be cleared by software. So this is the process that you need to do. Clear it by process in the software. So you can build out this one again. You can see that it will go back to the normal condition just now. So just run this one again. Then you will go back here. So that's the concept of interrupt. You interrupt something and you do something else. Okay, this is an example for RB0 interrupt, right? Okay, let's move on. So the next one, they call it what is it called? RB4, RB5, RB6, RB7 change interrupt. So again, the same process is you need to understand how it works, because it relates to the 4 pins here. The 4 pins are related to RB4 to 7. You must set up as a switch, and then the rest of the pins RB0 to RB3 must be grounded, or whatever. You must have a state for that one. Either you want to put it as a ground, or you want to put it as a 5 volt, which is 1. Okay, to use this one, right, for these pins RB0, RB4 must be configured as inputs. So you can see that in this setup for the void main settings, right, you can see that I start to put tries B here for all as 1. Okay, so this interrupt to occur, okay, configure as output. That if you put this as output, there will be no going to be interrupt happen again. Okay, so what happen is going to check the value between the current one, which is latch, versus the new one when you change anything on the switch. Okay, So the incon registers that you need to change is this one again. This is actually the one that you change. This is changing here. This is a global interrupt. You have to put 1 here. You remember that this is the one 1001 1001 0, so it's 1001. So you're going to use this one. This is RB4 to RB7 interrupt, and the partner will be here. This is the flag. The flag is still 0, right? You can see that the flag is still 0. So what happened is, when the interrupt happened, this RBIF is going to be turned on, but it does not require you to change it in the software. It will going to change by itself when you do the changes over here. So this is the interrupt function here. Okay, the interrupt function here. So you can see that this is a case. You can see that this is switch case switch. You remember that you have the if else statement. You have this type of switch looking at the value here. If this is a case, you're going to have this one. If this is a case, you're going to have this one. This is the case. If any of the input that you can see going to match this one. Okay, this one you can do it in your Proteus and macros. You try to do this one. I'm going to show you the example that I'm doing another version of this one, but quite simple, but you have to look at this one myself, my program over here. So I have another one here. So this is going to be RB47. Yes. Okay, where is it? Proteus. Okay, RB0 open project. Yes, it is an open project. Where is it? Hold on. So okay, before I open my this one, so let me find out this one. Sorry, open project interrupt. What's this one? Inside here, this one. Okay, this is quite messy a bit, but it nearly the same. So you have to look at how I draw my I connect all the inputs here. You can see the RB4 to RB7 is all connected to switch. So you have to do it to look at the results over here. So this is the input for RB4 to RB7. And then you have all the RB0 to RB3 is all grounded, which means that this is all 0, 0, 0, 0. This is now related to this one. This is by default, this is 5. You turn on the switch, is going to be 0. So my program is like this. Open listen files. It's nearly the same in the slide, but different. You can try this one. And you can try this one also. When you look at this one, right, so you can write down this one. This is my main program. Okay, this is my main program. You can see that at the tries B, I all set up as input all here. So it means that my port B is all input. Then you have the port B current state. You have the try C. Try C is set up as output, and the current voltage of all port C is at 0 volt. The interrupt control is set up by this one 10001000 is actually going back to this interrupt setup. This is we are going to use RB4 to RB7. Okay, then your main program is saying that whatever happened at port C is equivalent to port C. So the current condition at port C will behave at port C. For example, now the port C is nothing, right? So this is going to be nothing. When you run this program, it's going to be nothing first. So let's try to look at the program here. When I run this one, okay, it's nothing here. So that's I push one button here. Push one button. You can see that this is turned on. This is related to the first pin RB4, RB5, RB6, RB7. Is it terbalik? Sorry, this is going to be RB7 here. This is RB6. This is correct. This is correct. So you can see that my commands say that my program say that port C is going to be port C, but one interrupt happen, which is changes on the RB4 to RB7. It will go to this particular interrupt sections. So right now my current process here is just now. Okay, let remove this one first. The current condition is port C is equivalent to port C. There's nothing here. So right now I'm going to push this button. Push this button means that this is going to be 0. RB4 will going to be 0, and the rest will be 1, 1, 1, 1. So in my command say that if I see this RB4 is going to be 0 and the rest is all high, my port C is going to turn on the 4th LED. So the 4th LED is this one. This is correct. This is the 4th LED. This is the 3rd one. This is the 2nd one, and this is the 1st one. So it means that if I have this condition, I'm going to turn on the 1st LED. If I have this condition and I'm going to have another LED turn on, which is the 2nd one, this condition on the 3rd one. So you can see that when you run this one, this interrupt, right? This is the first initial stage. When you run this one, this is a interrupt had happened, and the command say that if you see this one as 1, 0, 1, 1, it's going to turn on the 3rd LED. So 1, 1, 0, 1, 1 is going to turn on the 3rd LED. So the interrupt flag, you are no need required to change it, because it's going to change by itself automatically when you read back this input. Okay, when you change this one again, you see this one, then you change this one. Means that no need to change any flag at your interrupt over here. So this is interrupt going to be happen, because now it's port C, right? All this one is going to be happen. So when you change something, the value here, your interrupt flag will be automatically cleared. So means that I change again this one, going to be change here, this one. So this value here, this value here. This is the way you can draw again and look at the results. Try to understand my program, which is much I want to make it simpler here. How do you want to write the program for the interrupt RB4, RB7? Okay, so that's the second one on how we are going to work on the interrupt. Okay, the last one they call it timer 0 counter overflow. This is you need to understand more of the option register. So I'm going to teach you one sections over here. So what you need to learn today is you need to understand, you need to memorize these types of interrupt. They call it timer 0. So this is a setup for the incon and the setup for the option register. So you're going to have a particular sections on this, because it's going to be very deep on the timing calculations. So to recap, today we have learned what is about the interrupts and the source of it and how it works. So remember that this is the register that you need to understand, and what is the function of it for all the bit here, and then this is the one that you need to set in your program when you want to work with the interrupt. Just now, for example, here you must have this incon, then you are going to work with the interrupt control. Okay, so this is your main body, and for the interrupt in micro C program, you can use the void interrupt function here. This is subroutine, so you can just name your subroutine as interrupt. So the system know that that will be your interrupt task. Okay, so this is the way how you have to set up, and this is about the option register related to timer 0. Not now. I don't want to teach you. This is timer 0, and then this is the example. You have to try it by yourself. In this example, you can draw this one. Yeah, you can try to use this one, but and also you can try my code. Just now my code is much simpler from this one. This one is more a bit complicated, but if you understand C++, you can try to understand what is count plus. This is all the commands or syntax that we use for the C++. Okay, so try to use it on my try to use both you can see that the results, how the result works. Okay, that's all for the 40 minutes lecture for the particular interrupts for today. So do not forget to complete the ULearn assessment, open at 10 AM today and up to 12 PM tonight. I give you a lot of time for you to understand this particular interrupt. Okay, so thank you very much. See you again on the next lecture.